There are all kinds of flashlights for all kinds of applications, but I'm sure if you've ever tried to compare the features of one light with another, based solely on the information on the packaging, I'm sure you've discovered that in most cases you can't even tell which light is brighter. The complete lack of any standardized testing or rating system has led to confusion for consumers, and real frustration for many of us who are committed to manufacturing quality lights and publishing accurate performance claims. That's why Streamlight was instrumental in forming a coalition of industry leaders to create standardized tests and a uniform rating system for flashlights. And I am pleased to announce that the new ANSI standards are finally here. Developed with the guidance of the National Electrical Manufacturers Association and representatives from 14 companies in the portable lighting industry, these standards help you rate and compare the most important features of personal lighting tools. These are the new symbols that are appearing on packaging. And in the remainder of this video, we'll explain what these symbols mean, how the tests are conducted, and what you should look for to be sure the light you're considering has been tested and how it stacks up to other lights on the market. Finally, there's a system that takes the guesswork out of buying personal lighting tools. And here's how the ANSI standard works.
Approved by ANSI, the American National Standards Institute, and developed by the Multi-Company Flashlight Standards Committee, the ANSI standards cover the following features: peak beam intensity, beam distance, impact resistance, runtime, light output, and resistance to water, which includes a water-resistant rating, a waterproof rating, and a submersible rating. Each flashlight company that participates in this rating system conducts its own tests, adhering to very specific guidelines. Here's what the tests cover, and a look at how these tests are conducted here at Streamlight and at other participating companies. Peak beam intensity and beam distance are both measured by the same test. The light being tested is aimed at a target that is placed 2, 10, or 30 meters away. The light output is measured by a candela meter that is connected to a light sensor on the target. Peak beam intensity is defined as the maximum luminous intensity typically along the central axis of a cone of light. The value is reported in candela. To determine peak beam intensity, the following formula is used. Surface light intensity times distance squared equals peak beam intensity. The same measurements are used to determine beam distance, which is defined as the distance from the device at which the light beam is 0.25 lux. The inverse square law is used to calculate the beam distance to 0.25 lux. Here's the formula used. Impact resistance is the degree to which a portable light resists damage when dropped on a solid surface. Products are dropped onto a concrete surface with all their intended parts and additions, including batteries, hand straps, etc. Minimum drop height is 1 meter. The height of this drop used at Streamlight is 18 feet. The drop test is also performed at 6 feet and 30 feet, depending on the light. Some lights, like the lanterns carried by firefighters, are also dropped down metal stairs to test their durability and impact resistance. Dropped samples must not exhibit any cracks or breaks and must remain fully functional in order to pass the impact resistance test. Runtime and light output are both measured by the same test using a spectroradiometer with an integrating sphere system and computing software to measure light output. Light output is a measurement of the total quantity of emitted overall light energy. It's measured by aiming the light into an integrating sphere, which is connected to a spectral light measurement system, which reports the light output in lumens, as shown on this graph. Runtime is defined as the duration of time from the initial light output value, that's 30 seconds after the light is turned on with fresh batteries, until the light output drops to 10% of the initial value. To find the runtime, the light output test is repeated every 15 minutes until the output drops to 10% of its initial value. And finally, there are 3 tests for the light's resistance to water. 2 tests are conducted using this submersion tank. One rates the light's ability to withstand temporary immersion in water under standardized conditions of pressure and time at varying depths. The other measures the light's ability to withstand continuous submersion in water. The light being tested is submerged for a period of 4 hours. We also use a special tank that simulates water pressure at any depth for lights that must withstand intense water pressure. A third test rates the light's resistance to water by splashing the light from all sides.
There's lots more technical information we can share with you if you're interested. Any questions can be sent to the email address on the screen. In closing, I want to emphasize that adherence to these standards and reporting results is strictly voluntary. So far, many of the leading flashlight manufacturers have opted to join us in making it easier for consumers to choose the best light for their needs. We hope that the entire industry will also follow these standards. The important thing for retailers and consumers to understand is this: if you don't see the ANSI icons on the package, you can't tell if or how the lights have been tested or how they will perform. But with this new standard, you have the information you need to make an informed purchase decision, and it's about time.